Good morning, guys. Today I want to talk about the relative dating principles performance test, or the ROC model assessment. So far in this lesson, we have learned how we can use relative dating principles to determine the geologic history of planet Earth. Over millions of years, we know that the landforms of our planet have been shaped by geologic processes such as erosion or seismic events like an earthquake. And we have the evidence of these geologic events that have been stored in rock layers. Today, you're going to create your own rock strata model with its own unique history. Your model will require all of our relative dating principles to understand its history. This is a performance task, and you are going to be creating your own illustrated rock model with labels and a written explanation that includes all of the details. So for this performance task, you're going to construct a model. Now I'll show you some examples of a model in a moment, but your model can be a digital image. You can take a picture of a drawing that you have done illustrating your model, or if you want to construct your model with supplies at home, like we did for our lab last week, you're welcome to use supplies at home to construct your model. However, your model will need a minimum of 8 rock layers and at least 2 geologic features. So that means like a fault line from an earthquake, or small rocks inside bigger rocks like an inclusion. Each of the layers and geologic features needs to be accurately labeled. So you need to include the number or the order of the sequence of events. The model must require 3 out of our 5 relative dating principles to determine the order of events. So you should need to use lateral continuity or superposition or cross-cutting relationships, 3 of the 5 principles in order to figure out the sequence of events. And lastly, your model should be colored and detailed. And then finally, you also need to include an explanation where you will go over the geologic history of your rock model. Your explanation should be about 1/2 to 1 pages in length. You're going to use scientific reasoning and logical reasoning to justify why each relative dating principle is applied. And in your explanation, I want you to address all of your layers and any of the geologic features that you have, such as faults, erosion, inclusions, or extrusions. So your rock model is really open to your interpretation how to complete it. It could be an illustrated model or it can be a constructed model. The assignment can be completed on a piece of paper or using Google Slides. I recommend that you all turn in your assignment using Google Slides though. If you're doing an illustrated one, just take a picture and insert it on the Google slide. Or if you're constructing a actual model, maybe out of Play-Doh, again, take a picture of your model and submit it with Google Slides, and then type in your explanation on a following slide. So I want to go over some of the examples that I have from last year. These are students that created digital rock models. I can quickly show you how they did that. Here's your rubric at the bottom on the second page. Make sure that you're checking the rubric so you do know what kind of grade you're going to get. So the rubric goes over in detail exactly the difference between the 4, 3, and 2. Some of the main points between the 3 and the 4 are, I should see that your model is neatly designed. It's easily identified. The labels are very neat. It has all 3 of the 5 relative dating principles. To get the 4, you're going to need more than the 8 layers. I should see a couple more layers in there. So you're just adding some extra detail. So here are some examples from last year. This student created, you can see they have 11 rock layers total. And then number 12 here is this erosional form, landform from erosion. Now they created this rock model here using the shapes. So they were able to just create these different shapes. And a simple way to do this would be to drop in your first shape. So this could be my first layer, and I'll give it a color. Then I can copy and paste it and drop it right on top. And this time I can just change the color. So this is a simple way for you to just kind of create your rock model using Google Slides in the shapes. This student created a similar rock model. Again, another rock model here. 11 layers. I see 2 geologic features. There is this extrusion right here at the bottom. And number 5 is a fault line. Number 7 is this inclusion. And then your explanation, I told you, should be about 1 page to 1/2 page in length. So here's an example of one of the explanations. I recommend that you pause it on the video at this point so you can read the explanation. In the explanation, it goes over details why this represents a rock formation. It goes into details how many layers there are and how many geologic features. And then in the explanation, it explains how they know the sequence of events. So it goes step by step in order, how they know the order of events. So for example, layer 5 is a magma intrusion, and it is younger than all the layers. It cut through because of cross-cutting principle states that if one geologic feature cuts across another feature, the feature that it cuts across is older. So if you just look at that sentence that I've highlighted, here's an example of a sentence I'm looking for. In your writing, you should describe what geologic principle you're applying. And then you can even write word for word the definition in your logical reasoning why you're applying it. So just take a look at this explanation on the screen here when you're going to write yours. Okay, here's one more example of another rock model. Again, they use Google Slides to take the image. I have plenty of examples of hand-drawn ones. I just can't include it on this YouTube video. And then finally, here's another explanation you can take a look at. A little less detailed here. Okay, so your job today is to get this rock model assessment done and turned in. Again, you want to have a minimum of 8 rock layers and 2 geologic features. Pay attention to this rubric that I've provided for you and go over the video as many times as you need, reviewing these rock model examples.